So now that we know what quadratic functions are, let's take a look at what its graph looks like. We talked about how this right here is called the parabola. This is a graph that every quadratic function makes, some variation of this. And we want to look at a couple of the characteristics. So the first word is axis of symmetry. So if you remember symmetry from geometry, that means that it's perfectly even on both sides, like you can look at it in a mirror. So the axis of symmetry for this graph is right here. And we know that since this is a vertical line, that it's a vux, so it's x equals, and it crosses here at 3. So the axis of symmetry for this is x equals 3. And basically, we're saying that the axis of symmetry is the line that divides the parabola in half. Right, because you can imagine if you folded the parabola along this line, it would line up right on top of each other. The next vocabulary word is vertex. The vertex is right here, where the graph changes direction. So you can see the parabola, reading it from left to right, it starts to decrease, and then as you hit this point right here, the vertex, it changes direction and starts to increase. So this is the vertex. The vertex of this parabola is 3, -4. The rest of the words should be pretty familiar. Our y-intercept. This particular parabola has one y-intercept. It crosses right here. Right, so it's the place where the parabola crosses the y-axis. Next we have our roots or zeros. Another word for these are x-intercepts. So we can see that this particular parabola has 2 x-intercepts. It has one right here and right here. We talked about how a 0 is the value that makes the function 0. So these are the 2 places where the function is 0. All right, and our last 2 words are domain and range. We talked about this back in Unit 1. Range are the y values of the graph. So basically we're looking how far up and down the parabola goes. We're following the y-axis, so that's why range is the y values. It's following the y-axis. So you can see up and down, this parabola doesn't go below -4. And even though we know the graph is stopping here, there are arrows here that are not written, and so we know it's going to continue going on forever. So 2 ways we could write this. We can use our set notation. The -4 is the lowest point, and since -4 is included, it's a bracket, and we know it's going to increase all the way to infinity. So that's one way you can write your answer. Another way is we could do it algebraically. We can say that all the y values are greater than or equal to -4. All right, they both mean the same thing. So if range is possible y values, remember that domain is the possible x values. So we're looking across, left to right. All right, so if you're following our graph, let's start at the middle. Let's start at the vertex. If you're following it to the left, and you imagine this keeps going on and on and on, does it ever stop moving to the left? No. If we start back here at the turning point at the vertex and we keep following this, does this ever stop going to the right? No. So 2 ways we can write our answer. We can say that the domain is all real numbers, or in set builder notation, we would write that as -∞ to infinity. Alright, so let's do one example together, and then I'm going to ask you to complete the last 3 on your own and have them checked over before moving on to the next activity. So let's start with vertex. We know the vertex is the turning point, so here it's starting to increase, and then right here you can see it changes direction and it starts decreasing. So this value right here at negative 3, 4 is called the vertex. The axis of symmetry we know is where it cuts it in half. So it looks like the parabola is cut in half right here at x equals negative 3. This parabola has 2 zeros. It has one right here and right here. So one of them is negative 5, 0, while the other one is negative 1, 0. Next we have the y-intercept. So I'm following the y-axis and I see that it crosses right here at 0, negative 5. And next I look at the domain. So I know domain are the x values. So if I start at the turning point and I follow my graph to the left, it looks like even though I don't have an arrow here, we do know it continues to the left forever and ever. This one's going to continue to the right forever and ever. So this is all real numbers, or if you prefer set notation, negative infinity to infinity. Let's talk about the range that's up and down. So we're looking up and down of this graph. So if I go down or up, I notice it doesn't go past 4. But I do know that it keeps going down forever. So it goes down forever, stopping at 4. Or you can write it as y is less than or equal to 4. Finally, one word we didn't talk about is open. So open is basically the direction in which the parabola starts getting wider. Since this is a frowny face, we say that this is opening down. It's going to get wider and wider as it's going down this way. If you look at our one above it, this one right here, see how it's a happy face? It's going up. So it's getting wider and wider this way. We say that this is opens up. There are 3 problems right after this that I'd like you to practice. When you're done, get them checked over and you can move on to the last assignment of the day.